Hello everyone. Today I am going to talk about the types and the reactivity of organometallics. There are the four types of the organometallics. The organometallics are classified mainly on the basis of the nature of the carbon metal bonds. The organometallics are classified mainly on the basis of the nature of carbon metal bonds. There are the four types of the organometallics. The first type is ionic organometallic compounds. First type is ionic organometallic compounds. Second type is covalent organometallic compounds. Third type is compounds with multi-center bonds. And fourth type is pi-coordinated organometallic compounds. Now, let's see the first type, ionic organometallic compounds. These are the compounds formed by highly electropositive alkali and alkaline earth metals. These compounds are formed by highly electropositive alkali and alkaline earth metals. In periodic table, group 1 and group 2 shows the alkali and the alkaline earth metals. These metals are the highly electropositive elements except the lithium, beryllium and magnesium. The bond between the carbon and metal. The bond between the carbon and metals. The metals are the highly electropositive elements, therefore this carries a partial positive charge and carbon carries a partial negative charge. The carbon is a more electron withdrawing than the metals. This carbon is an the group of the organic compounds. Therefore, these bonds becomes the more polar. These bonds becomes the more polar because these the metals are the electropositive elements and the carbon is and the electronegative elements. Now the bond between the carbon and metal here, the carbon is carries a partial negative charge, so that is called as a carbanion, and the metal carries a positive charge. These are the separation of the positive and the negative charges. Then the ionic character form here. Okay, the metal. For example, the metals are the used in this compound. The sodium, potassium, calcium. These are the highly electropositive elements. The metals are sodium, potassium, calcium are highly electropositive elements. These organometallic compounds behave like the salts. These organometallic compounds behave like the salt, and it is a soluble in highly polar solvents like the water. They are highly reactive. These are the highly reactives and shows the nucleophilic character and shows the nucleophilic character. Now the example phenyl sodium. Phenyl sodium this phenyl carries a partial negative charge and sodium carries a partial positive charge. This phenyl acts as a carbanion character. Sodium here the highly electropositive elements. The another example is sodium acetylide. Sodium acetylide. This sodium carries a positive charge and this acetylide carries a negative charge. Okay. The second type is the covalent organometallic compounds. Covalent organometallic compounds. These are the compounds formed with less electropositive metals like in a first type the highly electropositive metals are the used. Okay, in this type the less electropositive metals like the aluminum, zinc, magnesium are attached to the carbon atom. In this case, a sigma covalent bond is formed between the carbon and the metal. In this case, the sigma covalent bond is formed between the carbon and metal. These are the regular covalent bond. These are the regular covalent bond of the two electrons between the two atoms. We know that what is a covalent bond? That is a sharing pairing of electrons between the two atoms. Sharing pairing electrons between the two atoms. These are the regular covalent bond of two electrons between the two atoms. These carbon metal bond are partially polar. These carbon metal bond are partially polars. A carbon is attached to the metals. These metals are the less electropositive elements. Okay, therefore metal carries here the partial positive charge, carbon carries a partial negative charge. The polarity of the bond depends on the polarity of the bond is a depends upon the difference in the electronegativities values of between the carbon and metal atoms. The polarity of the bond depends on the difference in the electronegativity between the carbon and metal atoms. These compounds are less reactive. These compounds are less reactive and less soluble than ionic compounds. These compounds are less reactive and less soluble than ionic compounds. For example, RMgX Grignard reagents, okay, RMgX Grignard reagent, that is called as a Grignard reagent. The another example is iodomethyl zinc iodide, iodomethyl zinc iodide. The third example is diethyl zinc. Third example is diethyl zinc. Now the third type is compounds with multi-center bond. Compounds with multi-center bond. This compound can be considered as intermediate between the ionic and covalent organometallic compounds. Already we have discussed the two types. The first type is a ionic organometallic compound and second type is a covalent organometallic compounds. Ionic compounds, ionic organometallic compounds are highly reactive and shows the nucleophilic characters. Okay, covalent organometallic compounds are the less reactive and less soluble than the ionic compounds. The compounds with multi-center bonds. The compounds with multi-center bond. These compounds has an intermediate between the ionic and covalent organometallic compounds. This type of compounds, which is a between intermediate between the ionic and the covalent organometallic compounds. The bonding in these compounds is not of the bonding in this compound is not of conventional two electron two center types. The bonding in this compound is not of conventional two electron two center type. They involve three center bonds. They involve the three center bonds and they are the electron deficient in nature. Means you see this example here, there are the three centers. It's 1, 2, and 3. Three centers, okay? Three centers, okay? These are the two centers, okay? Two center, two electrons. R and the bond between the alkyl and the aluminum. These are the two center, two electrons, okay? Two center, two electrons. This is another two center, two electrons, okay? There are the two centers and two electrons. When the one bond is a make, there is a need of the two electrons. There is a need of the two electrons. There is a need of the two electrons, okay? Now they are the three centers, 1, 2, 3, okay? They are the three centers, two electrons, 1, 2, 3. The bonding in this compound is not of conventional two electron, two center types. They involve the three centers. They are the 1, 2, 3 centers, okay? They involve the three center bonds. They are the electron deficient in nature. And they are also called the non-classically bonded organometallic compounds. They are also called as a non-classically bonded organometallic compound. For example, dimeric trialkyl aluminum. Dimeric trialkyl aluminum. This is an example of dimeric. Dim is two. They are the trialkyl, okay? Trialkyls, okay? Trialkyl aluminum. Trialkyl aluminum. Means you see the structure like that, okay? They are these two molecules, okay? This is the first molecules. There are the three alkyl groups which is attached to the aluminum. This is another group, okay? These are the di, okay? This is another groups, okay? Now here the bond between the alkyl group and the aluminum. So the two center two electrons. These are the two center two electron, two center two electron, two center two electrons, and these they are the two aluminum are aluminum. aluminum, R, aluminum. These are the three centers. 1, 2, 3. This is another 1, 2, 3. These are the three centers, two electron type. Okay, these are the electron division in nature, and they are also called as the non-classically bonded organometallic compounds. The next type is a pi coordinated organometallic compounds. Pi coordinated organometallic compounds. The unsaturated compounds like alkenes, unsaturated means carbon-carbon double bond or triple bond are present. Okay, unsaturated compound like alkenes, alkynes, etc. have localized the pi bonds. In a carbon unsaturated compound, the pi bond is present. Okay, double bond in a triple bonds. Okay, alkenes and alkynes have localized the pi bonds. The benzonide. What is a benzonide? The benzene present in that compounds. Okay, benzonide means the benzene which is a present in that compounds. For example, naphthalenes, okay, anthracenes, and non-benzonide. The nature like these are not a benzene ring is present in that compound, but they have the character, aromatic characters. Okay, these are the benzoid character. These benzonoids and the non-benzonoid aromatic compounds have delocalized pi electrons. Benzonoid and non-benzonoid aromatic compounds have delocalized of pi electrons. These pi electrons or lone pair of electrons can coordinated with the transition metal ions. Here the iron is a transition metal atoms. These are the two 5-member rings. Okay, and the iron which is between the two 5-member rings. Okay, the pi electrons and the lone pair of electrons can coordinated with this. These are the lone pair of electrons. These are the pi bonds. Okay, these are the pi bonds, and these two pi bonds which are the coordinate with the transition metal ion forming the complex, and hence the carbon metal bond. These are the carbon here, the carbon metal bond, this carbon iron bond. So the carbon metal bond is a coordinate bond. This carbon metal bond is a carbon iron. Here also the carbon iron. This carbon metal bond is a coordinate bond. This bond is called as a coordinate bond. In case of cyclic compounds, the metal atom lies between the two rings. The metal atom lies between the two rings. In other example, also chromium is between the two rings. Okay. In case cyclic compound, the metal atom lies is between the two rings, and hence they are called as a sandwich compounds. These are called as a sandwich compounds. The metal atom lies in between the two rings, and they are called as a sandwich compound. The iron is between the two rings. Okay, these are called as a sandwich compounds. For example, Fe2 and the chromium atoms, Fe2, iron 2, and chromium atoms are coordinated with the delocalized pi electrons. They are the iron and the chromium atoms are coordinated with the delocalized pi electrons. In natural organometallic compounds like cyanocobalamin. In the natural organometallic compounds like cyanocobalamin, that means the vitamin B12, chlorophyll, and heme, the metal like cobalt, magnesium, and iron, respectively. In vitamin 12, the cobalt atom metal is present. In chlorophyll, magnesium is present, and hemoglobin, the iron is present. Okay. These are the coordinated with this lone pair of electron. On the nitrogen atoms in the organic compounds. Means these are the metals are present in vitamin B12, chlorophyll, and hemoglobins. Okay, and these metals which are the coordinated with this lone pair of electron present on the nitrogen atoms in the organic compounds. Okay, now here complete the types of the organometallic compounds. Thank you.